Somewhere under downtown Seattle, there are pieces of an $80 million machine that nobody ever dug back up. They didn't lose it. They knew exactly where it was. It was simply cheaper to leave parts of the largest tunnel boring machine ever built where they sat than to haul them back to the surface. Her name was Bertha. She was 5 stories tall at the cutting face, roughly 7,000 tons, and she was built in Japan for one job: to dig a 2-mile highway tunnel under the middle of Seattle. She made it about 1,000 feet, then she stopped. And what happened next? The 2 years of silence, the rescue shaft sunk from the street above, and the fight over who broke her is one of the strangest engineering stories in modern America. Not because anything exploded, because for 2 years, the most expensive machine on the continent sat motionless in the dark under a city, and nobody could agree on why. Start with why Seattle needed the tunnel at all. For most of the 20th century, the western edge of downtown Seattle was defined by the Alaskan Way Viaduct, a double-decker elevated highway running along the waterfront, carrying State Route 99 right past the piers. It was built in the early 1950s, when running a highway across the city's waterfront was considered progress rather than vandalism. Then, in February 2001, the Nisqually earthquake hit. The viaduct did not collapse, but it was damaged, it settled, and engineers who looked at it afterward concluded something uncomfortable. The structure sat on soft fill along the waterfront, and in a larger earthquake, it would likely come down, with traffic on both decks. Seattle now had a highway it could not trust, carrying tens of thousands of vehicles a day through the most valuable real estate in the city. The debate over what to replace it with ran for years. Rebuild the elevated structure, replace it with a surface boulevard and better transit, or bury the whole thing. Seattle chose to bury it. A deep-bore tunnel running beneath downtown, deep enough to pass under the buildings rather than between them, which meant somebody had to dig it. The machine built for the job was, at the time, the largest tunnel boring machine in the world. Bertha's cutter head measured roughly 57 feet across, wide enough that the tunnel it carved could hold a 2-level roadway inside. She was manufactured by Hitachi Zosen in Osaka, shipped across the Pacific in pieces, and assembled in a pit at the south end of downtown Seattle. The machine itself cost around $80 million. The tunnel project as a whole ran into the billions. And a machine like this is not really a drill, it's a factory that moves. The cutter head grinds forward at the front while, behind it, crews assemble concrete rings that become the tunnel wall, and conveyors haul the excavated soil back out. It advances a few feet at a time continuously, and it is designed to never stop, because stopping is where the problems start. Bertha began digging in July 2013. By early December, she had gone roughly 1,000 feet into a bore of about 9,000, and then the readings went wrong. Temperatures climbed in the seals around the main bearing, the enormous rotating joint the entire cutter head turns on. Pressure rose in front of the machine. She slowed, and then she stopped entirely. That was December 2013. She would not move again for 2 years. The first explanation to reach the public was almost too good. Crews found a steel pipe in the excavated material, an 8-inch well casing buried in the ground directly in Bertha's path. And when they traced where it came from, the answer was that it had been installed years earlier during groundwater testing by the State Transportation Department itself. The story wrote itself. The agency building the tunnel had left a pipe in the ground, forgotten it, and then driven the world's largest tunneling machine straight into it. Except the engineering did not really support that. A machine of that size, grinding through glacial soil, is designed to chew up obstructions far more substantial than an 8-inch pipe. Analysis afterward pointed elsewhere, toward the seal system around the main bearing, which had failed and allowed grit into places grit must never reach, which opened the real fight. Was the machine damaged by something in the ground that should have been mapped? Or was it a design and operation problem in the machine itself? That question was worth hundreds of millions of dollars, and it went to court. The state and the contractor spent years arguing over who was responsible for the delay and who would pay for it. Litigation that outlasted the construction. Meanwhile, Bertha was still down there, broken, 200 feet below the surface, under a working downtown. Here is where the project stops being an engineering problem and becomes something closer to surgery. You cannot repair a bearing that size from inside. The damaged parts were at the very front of the machine, behind a cutter head pressed against the earth. The only way to reach them was to take the front of the machine out of the ground. So they dug down to meet her. Crews sank a vertical access shaft from the surface directly in front of where Bertha had stopped, an excavation roughly 120 feet deep in soft ground next to the waterfront in the middle of a city. They braced it, sealed it, and pumped the water out. Then they lifted the front end of the machine, a section weighing about 2,000 tons, straight up out of the pit with a crane in pieces, and set it on the surface for repair. It is worth pausing on that. To fix a machine that was digging a tunnel, they had to dig a hole down to the tunnel, pull the front of the machine out through it, repair it in the open air, and lower it back down. And the shaft itself became its own crisis. Dewatering an excavation that deep, that close to the water, pulls groundwater out of the surrounding soil. And when groundwater leaves soft ground, the ground above it settles. Nearby streets and structures did settle, measurably. At one point, a consultant's letter about the risks to the shaft used the phrase catastrophic failure, and that phrase escaped into public view, forcing state officials to appear before the Seattle City Council and explain exactly what had been meant by it. The repairs took roughly 2 years. Bertha started digging again at the end of 2015. And then, she finished. On April 4, 2017, the cutter head ground through the final wall of concrete and fiberglass at the north end of the bore and broke into daylight to a crowd. She had gone the whole 2 miles. The tunnel was dug, and that was the end of her. There was no next job. Bertha had been built for this bore at this diameter, and the economics of shipping a 7,000-ton custom machine somewhere else did not work. She was taken apart in the disassembly pit where she surfaced, cut up, and hauled away in pieces, except for the parts where removal made no sense, which stayed. The tunnel opened to traffic in February 2019. The Alaskan Way Viaduct was demolished the same year, and the waterfront it had shadowed for 65 years was opened up. Drive State Route 99 under downtown Seattle today, and it is entirely unremarkable. 2 levels of clean, lit, modern roadway. Nothing about it suggests that the machine that made it sat dead for 2 years while lawyers argued and the street above it sank. So, what do you take from this? The comfortable version is that it's a story about a mistake, a pipe, a seal, a contractor, somebody to blame. The more honest version is that mega projects like this are not really built on engineering. They're built on estimates of the unknown. Bertha was digging through ground that had been surveyed, sampled, and modeled extensively, and it still contained enough surprise to stop the largest machine ever made for 2 years, 1,000 feet in. Every deep bore is a BT that the ground is what the boring said it was. Usually that bet pays. The tunnel under Seattle is a monument to what it costs when it doesn't. They dug a hole to rescue the machine that was digging the hole. Then they finished the tunnel, cut up the machine, and left what wasn't worth lifting exactly where it stopped. Thanks for watching. If you want more of the roads America built against the odds and what they cost to keep, subscribe. There's a lot more out there.